Yeah. So today we are going to learn about concepts and applications of machine learning in food and nutrition research. And this is from a beginner's perspective or from a beginner's point. So in this session, we will also look at some of the basic applications of machine learning in maybe other fields, and then we will come to food and nutrition research also. Okay, so let me just maximize my screen. Yeah. So what is learning? How does a child learn or how do we learn? So like whenever any text comes to us, we go through it, make some connections in our brain, which are called neural connections that are automatically made when we process that material, and then we are tested or examined whether what we understood was correct or not, right? And then we get a feedback in terms of our marks, and then if it is good, we go ahead. If it is not good, then we memorize it again, try to understand our weaknesses, and then we proceed with it, right? So this is in layman terms the process of learning. Now, how does it happen in case of machine learning? Like, for example, how is a machine or an AI system able to recognize what is the handwriting, whose handwriting is this, right? So, recognizing and classifying handwritten words with images. How is that possible? So, before I explain it further, I would like to introduce this kind of graphic. So if we see input raw data, so for example, when we are giving, let's say we are, if we want to train a model using labeled images of cats and dogs, we will come to our handwriting example once again, but let's just build some theory around it. Okay. So if you train a model using labeled images of cats and dogs, it learns the features of each. Okay, so what we are telling is, let's say we are giving the system an input raw data of cats, dogs, or camel, elephant, cow, or whatever the animal is, and we are sharing also some of its characteristics like weight, size, and other characteristics, the food it eats, and all that. And we are labeling it also. Like this is elephant one. This is and these are the characteristics of elephant. These are the characteristics of cows and camels and so on. Right. So there is a proper raw data set in which we are mentioning elephant, its characteristics in the other columns, and so on for each of the animals. Fine. So when this is a labeled data, because we are mentioning the animal name also in it. Okay. So when we insert it in the system or the algorithm, it trains the data set and it generates a desired output. Okay. So initially we input the data, all the data with camel, cow, elephant characteristics, and then we ask, then when the AI system is trained, okay, like if this is a heavyweight animal, it must be elephant or something. So that's how it will train itself. Okay, these characteristics belong to this kind of animal, right? Similarly, if the height is very high, then it will say that if the height is like that, it must be camel. Right, so it learns from the training data set. Now, come to the processing part here. When you give any unlabeled characteristic, let's say you make it in such a way that the weight is comparatively less and the height is very high, right? So, in that case, it will return the output. The computer will give the output that it is a camel, right? Because it has learned from the characteristics from the labeled data. Okay, I hope this is making sense. So similarly, we will look at some couple of other examples also, like handwriting recognition learning problem. So what actually happens in this, like you give handwritten notes to the computer and you tell it like, for example, this is a computer. If, for example, this is written in a handwritten form, then you tell the computer, label the words also in typed form. This is a computer, and also write it in handwritten style. Okay, so you're giving it labeled words with images. So you're giving it labeled words with images of handwritten form to the system, and then it classifies. If you give, then when it goes to the system learns, and when you then give it a fresh piece of handwritten notes, then it will tell you whether the data set of handwritten words, what are the words in it, right? And how does it give a, what is the parameter in this? Like, how will we assess whether it is given right or not? One aspect is that a human should check whether it is telling right or wrong. The other could be percent of words correctly classified. Now, where is this coming from? Percent of words correctly classified. So basically, whenever we input a data set, let's say we input raw data set, we have both training data set as well as testing data set. Okay, so in case of training data set, whatever we input, let's say 80% of the labeled data is coming under um, training data set, and 20% of the data is coming under testing data set. So when it is coming this way, then we will train the AI with 80% data set and then test it as we are tested in the exam through that 20% data set. And this 20% data set, it has to reveal whether it is uh, the 20% data set is also labeled. So it is tested, like whether it is whatever output it is giving, whatever answers it is producing, is it right or wrong? So when in handwriting example, once again, when we recognize and classify handwritten words within images, we test it using percent of words correctly classified, and then we for that comes from the testing data set and test data set, and then we get a response that okay, this let's say we get 95% accuracy or 99% accuracy, then that means it is good enough. Okay, now coming to another example, a robot driving learning problem. There are some robot drivers also. If we want to introduce robot drivers, then what will be the task? How will they learn it? So they will drive on highways using vision sensors, and they will basically learn from um, sequence of images and steering commands recorded by observing a human driver. So driving on highways using vision sensors and sequence of like it will make a record of how does a human respond whenever it comes across any obstacle, any other car or any other vehicle, then how does it respond? What steering commands it gives? What images it so through these images, this AI robot, it learns from this process, and how its performance can be measured or tested using average distance traveled before an error. Right? So this is a way. So now let's look at the last problem in this slide, a chess learning problem. Playing chess. So when it plays chess, playing practice games against itself. So it can learn from its own experience if it can just enter the some rules. If the rules are entered into the system, like if you go like 3 points ahead, then you will, if you then these are the rules, so and so all the rules, and if you go 3 points ahead, then you will kill this pawn, or such kind of things can be taught through chess learning problem to the system, and then it will when it plays chess. Okay, then percent of games won against opponents or against itself or against opponents can be a performance measure. Okay, so now there are three types of machine learning. One is supervised machine learning, in which we provided input raw data which is labeled. As you can see, like we just discussed, that elephant, camel, cow, they are all labeled. And the output they are getting, elephant, camel, cow, sorry, the test and the training data both are labeled, right? Then unsupervised machine learning. So in unsupervised machine learning, input raw data is there, and it is not labeled. So if we have customer data, for example, without labels, the algorithm can group similar customers based on purchase behavior, useful for segmentation and marketing. So like we enter the input raw data into it, which is without label. The model is trained on understanding the patterns of each kind of data that we are doing the input of. Okay, like for example, it is again the weight is there, height is there of several animals is given. So it will just gather like, okay, this cluster has this kind of average weight, this kind of average height. So it must, if it is very high, it must be an elephant. So it can generate output on this basis. Now, how it will apply to the practical research problems. So, like for example, if you're studying personality types of, let's say, those people who eat a lot, okay, like maybe those who do binge eating, or or those who are underweight, or those who are overweight or obese, then you will find it some kind of pattern in their personalities, in their eating habits. So then you will be able to you are inputting the data without any labels. You're just giving the system some characteristics, and when the output will come, it will also come with their personality types maybe, or connecting personality types with eating habits could be a research problem in this case. So this is about unsupervised machine learning. Then last one is, so mainly it is of three types. There are some other classifications as well. But let's come to the third type, which is reinforcement learning. So, like for example, we are training the system to learn to play chess, and it gets a positive feedback for good moves and negative for poor ones. Like for example, when AI, you must have experienced this. Like when we enter some prompt in the AI system, and then it gives us a response, we can either give a thumbs up or a thumbs down, right? So when we give a thumbs up, it actually learns that it has produced a good output. And when we give a thumbs down, it learns that there is some other output which has come. Yes, sure, you will get a document also. Yeah. There was a message in the chat, so you will get the document also. Yeah. So through this feedback system and reward system, agent, action, environment, it learns, and through the reward it understands whether what is it is learning is right or not, and then if it is not right, it tends to improve itself. Okay, so what I'm sharing, why it is important, because it lays the foundation of the practical thing that we are going to do sometime ahead in this session. So if you can pay attention to this, it will be great, because now we are going to look at the examples from food and nutrition, which are taken from this art research article. So, like how AI-driven dietary assessment and food recognition is possible, right? So, identify the task is to identify foods from images and estimate portion sizes. Experiences annotated food image data sets with labels, portion sizes, and nutritional values. Right? So what does it mean? Like let's say you're giving input of images of food and trying to estimate, and you want this AI system to tell which food is this and what is its portion size. Right? If you want the AI system to do this, how will you make it learn? Through annotated, meaning labeled, food image data sets with labels, portion size, and nutritional values, right? So, like for example, if you're giving it idli, then it will just label it and write the portion size, the nutritional value and label, and then it will, when it goes into the system, if any such thing appears in maybe high size, greater size or lower size, then it will be able to identify, okay, this is this kind of recipe, right? And this is the portion size, estimated portion size. So, like we just went through the supervised learning, this is example of the same, right? How can personalized nutrition planning and metabolic prediction be done through machine learning? Right? So generate individualized diet plans and predict metabolic response to foods. So for this, let's say you want to generate diet plans for individuals and you have the uh, patient's data sets which have like physiological, genomic, lifestyle, dietary and health outcome data is there for many patients and their diet plans also is there. Okay, so you first train the AI through this process. Like, so AI learns, okay, these are the characteristics of their physiological characteristics. These are the characteristics of their physiology. Then this should be the diet plan. Okay, and how will you measure it? Like how satisfied is the user from this system, from this AI system. Clinical outcomes also can be like HbA1c, weight loss, lipid profiles. Like through this outcomes also it will tell like whether it is the right diet plan or not, and adherence rates also. Like if it is counseling well, if it is being trained well, if the system is trained well, it is able should be able to counsel well also. So when such sheets are entered into the system, we will see when users use it, how much are they able to adhere to this guidelines of diet plans, right? Then,
Ma'am, what is TP and E like? Can you just tell me?
yeah,
TP and E.
yeah, sure. So let me go to the first slide. So E is the experience, T is a class of tasks, and P is a performance measure. Okay, so basically, like for example, that we were just um, doing, yeah. So task is T's task that is given to that question to that AI system. P and experience, like how will it train itself? So what experience will the AI go through to train itself? Just a second. Yeah. So what experience will the AI go through to train itself? Like patient data sets with physiological, genomic, lifestyle, all this data set will be input in the system, right? So this is the experience that the AI go through, and how will it be validated? Like whatever output it produces, how will it be validated through clinical outcomes? Right, and thank you for that question. If anybody has any question in between, they can also ask. So this is how individualized diet plans and metabolic response to foods can be predicted in a theoretical sense. Okay, I hope I answered your question.
Yes, ma'am. Thank you.
So, clinical decision support in chronic disease context. So, so can anybody try to decode it? Like, what is tasks, experience, and performance measured in it? Like, what is the task? So the task is, okay, I got a chat, I think. Yeah, so that's what I'm doing. Okay, so like the chatbots that are there in, let's say, some of the Healthify kind of apps, or some diet related apps. What do they do? You understand chatbot, right? In which you just enter um your problem and you get a solution out of it. Right? You enter your problem in terms like you maybe upload your pathology report also, or any chronic disease management thing, like in Healthify app, you get a personalized diet plan also, which is checked by a human, right? So those chat bots that you see, they are an example of AI, in which the AI or has learned through machine learning. The AI system has learned through machine learning. How it has learned? Through clinical data sets. Like if nutrition interventions are entered in that system, like for this disease. So I'm just explaining how this chatbot or AI system would learn. If some clinical data sets and disease of the disease specific population, meaning the patients who are suffering from some chronic disease, if their data is entered into this system, and the management, how they managed it, how they recovered from it, what diet plan they used, and what were the solutions that were suggested to them. If this kind of raw data is input in the system will learn, and when you enter any chronic disease name, it will recognize from the data what decision or what suggestion it needs to give, and then it will provide it. Okay. So, like generative AI and conversational agents in patient education. So, like for example, if you are asking ChatGPT, like you are my dietitian and I'm your patient, you're just giving it a role, basically the role kind of prompt you're giving it to start with a basic example of how this generative AI and conversational agents can be helpful in patient education. You're just giving it a prompt, play the role of my dietitian. I have this much of weight, this much of height, and it will calculate your BMI, and you give it some other characteristics of yourself also, and what you like to eat, what you do not like to eat, what is your impulsive behavior when it comes to the diet, and so on. Then it will be able to process the data, and it gives you some of the response. Okay, that maybe you can eat these kind of recipes or dishes in your breakfast, and you can switch to lunch with these dishes. And if you do this way, walk these many steps, then you will have a calorie consumption of this much, right? So if you just give it to an AI chat, maybe chat GPT or just any AI, if you make it your dietitian, it will provide this kind of output that I just told you, right? But how does it learn? That's what I'm trying to explain. So it will learn through the raw data that you give, labeled raw data. So let's say you give data of all the dietary advice that was, you just get the transcripts of all the dietary advice that was given to, let's say, many of the dietitians, okay, some of the good dietitians, and you collect transcripts from them and the problem of the patient, and let's say you collect thousands or 10 thousands of such documents, okay, and then you enter into chat gpt or system which has already been done. You don't need to enter into chat gpt, like how ai learns. That's what I'm explaining. So such kind of documents would have already been entered into chat gpt. That is why it is able to give you the right kind of advice, right? So I'm not saying chat gpt is always correct. I'm just saying that generative ai, like ChatGPT's chatbot, or um, Healthify Me chatbot. So all this kind of chatbots use such kind of um, training data. Okay.
Ma'am, I wanted to ask regarding the validation question, the P aspect of it. How does it learn about that? Like the comments that we give to ChatGPT through that, or like when we say improvise or make it better, is it that ways that it learns that this is not the right output, or the P aspect I am trying to understand. I got the topic and the experience, the P aspect here in the fourth example, or
Yeah,
like any
yeah,
example.
yeah. Thank you for that question, Shravani. So, how it learns is, so there is one training data, like the data you just input it. Let's say there are 100 such transcripts, okay, that you input in the system. So it uses 80 transcripts out of those 100 transcripts for learning, and then it is tested on 20 transcripts out of those 100 transcripts. Okay, so like for example, we are tested in our exam with whether what we learned is right or not. Similarly, AI system will be tested. So that is test data, and the former thing, which is 80 of the files, will be um, training data set, right? So on this test data, it will check for its accuracy and consistency of information. Like, let's say the person is obese and he has certain characteristics of maybe binge eating or something. So the AI should be able to give the right diagnosis and the right treatment to it. So it is both ways. Like you said, it also works on the user satisfaction, like you were saying, right? Feedback loop and all that. That will come under user satisfaction. And accuracy and consistency of information will come when we are dealing with the test or exams of that AI. Okay,
Okay.
like, yeah, so you understand, right?
Yes,
That
yes, ma'am.
okay, okay, great. So this will help AI in knowledge improvement also.